All right, briefest overview. I plan on looking at this again later when these things make more sense. But there will be 100, like most of my non-final exams, the exam is out of 100, but there's 105 points on it. Included is a one-page Amuse Me, which gets torn off, and I get quite the collection of them, so, have fun doodling for me, I guess. A number of questions on the exam. There's a few questions that are theoretical that will require you to draw linked lists. So basically squares with arrows. Don't worry if your artistic skills are as bad as mine. But the vast majority of this exam goes over linked lists, which is what our topic is going to be today. The one thing I do want to mention is this 20-point question, which is a bit more abstract here. Let me just read it. A list can be implemented in a number of ways. Compare and contrast an array list and a linked list. In which situation would you want to implement a list over another? In other words, compare and contrast array lists and linked lists. On the exam, I write out how I want you to compare them, which is memory usage, add and remove methods, and get and set. I will be going over these answers. Analysis again. I'll be going over these answers, on the Tuesday before the exam, as well as any time during office hours, or any meeting with me. If you want to know the answers, I'll be happy to share that specific. However, this one is a particular note because it is worth 20 points. There's basically an exact one-to-one replica as written on the exam, which means 20 points of the exam going into the exam, and you have a cheat sheet, which means you should probably write down your answer beforehand, right? And especially since I'll be giving you the correct answer on Tuesday, that means you should be getting a guaranteed 20 points, right? So, however, that being said, I will keep asking this question on my exams, as I have for the past decade or so, until people stop getting it wrong. There's always people who don't show up to class, and then they get and they don't bother watching the practice exam video and get absolutely walloped. So, thanks, I guess, to the people who did that last year. Some of these methods are pretty interesting and fun, and and good ways to kind of do this. But again, linked list is kind of our first big hurdle of the semester, and the reason being for that is because we are going to be getting into phrases that look like this. Node.next is equal to node.next.next. Okay? These can look very confusing if you don't know what's going on. But the important thing to remember when you're doing this stuff is that this thing on the right side is a memory location. Okay? This is a memory location. It's basically the address of something, and it gets stored in this thing on the left. This is a variable. So you're taking whatever memory location is in here and storing it in here. Nodes.next variable. Okay, and I go over, and I have a lot of drawings about what exactly this is doing. So just simply watch those videos if you're lost, because those videos are very illuminating. I put a lot of effort into those because I know how difficult this portion can be. The good news is once you get through this, basically it's not going to get any harder. It's basically this is the hurdle. Ensuring that you understood how memory locations work, and how this assignment statement works from the last couple of semesters of programming. Okay, this is where that really comes into focus. I also try to break down how to program linked lists in a bit of a different way than the textbook does, because I feel that the way I do it is a lot logical because it does not require nesting multiple if statements. I try to make my if statements, yeah, there's 5 of them for add and 5 of them for remove, but the way I do it makes it a lot less complicated. Okay. Now let's talk about your assignments for this semester. Sorry, for this week. You have a bit extra time because these are a whopping double assignment, as I would put it. They're due the 16th. I'll probably make that due the 17th, so the day before the exam, because I want you to have these done before the exam. But you'll have a bit longer than usual to work on them. They're worth 200 points. One of them, and you only have to do one of them. Okay? If you're feeling more comfortable with the material, go and try the Josephus problem. If you're feeling less comfortable, try the Josephus. If you're more comfortable and have the time, that's another thing. This one does take more time. Do the solitaire encryption. I've done both as the only option for the semester in this class, and I like them both, so I just simply give you a choice. So they're both doable. Okay. Now, both of them use the exact same circular linked list, although the interesting part is that, like, Josephus will use some subset of the stuff, like it will use the iterator, whereas the solitaire does not need to use the iterator. So I'm going to open this up. Geany. I'm going to open this up in Geany. And open that in date modified circular linked list, so we can just simply zoom in. So first things first, I do have this in a package. You can remove that as needed. You can remove this line if you don't need a package. The second thing is like over here, you'll notice that I have an import iterator, and circular linked list implements iterable. This is the class that needs to exist for a object to have a for each loop around it. Okay, to be usable in a for each loop. You don't want to use it in a for each loop though, as you'll find out soon. But there are some stuff that I've already implemented for you. Okay. But I tell you, hey, do this. This is exactly the same as doing the what I do in the videos. And in fact, the add methods and the remove method, okay, are actually very, 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 very similar to doing it with a doubly linked list. You just have to adjust for the fact that this linked list is what is, as we say, is circular. I already have a working two-string method for you. And I say working because it's designed to break if your code breaks. If you've done it incorrectly, it will crash. So this works. If you have issues, it's your dang fault. You know, it's meant to work correctly. Finally, this iterator is useful for to manually to iterate through. You can use this method to get what's called an iterator, and the iterator is right here, and it has 3 methods that I've already programmed for you. The first basically says, hey, is there a next item? It's circular, so if there's any items, then yes, because it's a circle. Next, we'll give you the next item, and it automatically handles wrapping around and the indexes for you, so you don't have to worry about that. And then remove, which will, again, this helps you with the Josephus problem. So if you're doing the Josephus problem, this remove method is helpful, but it doesn't. But I cheat and I use your remove method to do the removal to make sure it's working. Okay, so. So the big difference between the Josephus problem and the solitaire, mechanically speaking, is if you do the Josephus problem, this is basically the only thing you need to fill out. You just need to do this, you test it, and then you write your main function to solve the Josephus problem, which I'll get into in a minute. If you're doing the solitaire encryption, this is just the beginning. You have to make a separate file for doing the actual shuffling of the deck and the manipulations. So I'd say it's about maybe twice as long to do the extra credit. But the good news, what this means is you can choose either one to do. And if you feel you have more time, you can, and you originally chose Josephus, you can go and do you can go and do the solitaire encryption. And if you essentially said, well, I'm gung-ho, I'm going to try the solitaire encryption, and you find that was a bit more than you could do, then you can just easily back off and just pivot to the Josephus very easily. So there's very, very little wasted time in either problem. So let's go ahead and actually talk about what those problems are. So the Josephus problem is named after a very early historian, Titus Flavius Josephus, who lived from the extremely important era of 37 to 100. So let's go ahead and get his name and basically find out who this guy was, okay? Because he was kind of important, if you're, especially actually if you're Christian. Because note the dates that Yosef ben Mattiyahu was lived. But of course he's known by his Roman name, Flavius Josephus, as we'll see obviously for a while. So 37 to 100. That is the time. That is a big part of the time where that's basically what historians would refer to as early Jewish Christianity. Basically, where Christianity hadn't fully become its own religion yet. Right? It was still kind of forming as its own, let's say, religion. But he was a big historian, and he wrote a lot of historical documents, including some contemporaneous record of Jesus of Nazareth. So that's kind of important because this is a non-biblical source. You know, so it's very, so he's got like the Jewish War, right? Right? Antiquity of the Jews recounts the history of the world from a Jewish perspective for an ostensibly Greek and Roman audience. These works provide insight into first century Judaism and the background of early Christianity. Right? Josephus' works are the chief source next to the Bible for the history and antiquity of ancient Israel, provide an independent extra-biblical account of such figures as Pontius Pilate, Herod the Great, John the Baptist, James, brother of Jesus, and Jesus of Nazareth. So pretty important historical figure. Now, how did we get here, and why are we learning about religious history and history in general in our computer science class? Because, I mean, it's not just because I'm wearing a kippah here, right? It's all right. So Flavius Josephus was basic. So for those of you who don't know, basically, the Roman Empire was in control of a great portion of the world during that time. Here is the expanse of the Roman Empire a bit after Flavius Josephus' times, and you can see that basically we've got a lot of what would become later smaller empires, like the Ottoman Empire and the Spanish Empire and the French and the bit of the Germans, right? And so the basically the Roman Empire owned a lot of stuff, took over a lot of land, and during those age when you don't have near instant communication and traveling takes a while, right? It takes a while for basically some people get, let's say, uppity and decide, you know what, actually we really do not like being part of this empire. We pay taxes. What do you do for us, right? So they go ahead and they revolt. Now the Jews revolted back, let's say, what was the time? I have it in the document. They had an uprising against the Romans. 67, right? So Flavius Josephus served as a general during that uprising, and he basically got sieged eventually because the Romans, it turns out, were very, very, very good at war. There's a reason that they painted that big portion of the map red, right? So most revolts against the Romans went very poorly, and this was no exception. So basically, they were the idea behind this problem is that Josephus and his war band, they were all trapped in a cave, being besieged by the Romans, and the Romans were saying, "Surrender, and we'll just make you slaves." It's not the worst thing in the world, and essentially. The overwhelming response of the army was death before dishonor, and they decided to basically all kill themselves rather than go and become slaves. So essentially, the way this kind of worked, apocryphally, was that they basically lined up in a circle and they drew lots as to which one of them would be killed by the other. And then this continued until it was only Josephus and some other dude left, and I guess they kind of looked at each other, looked at the bodies of their friends, and went, well, this was a terrible idea, and then surrendered to the Romans. Josephus was then a slave for about 7 years, but he made the miraculous prediction that the Roman general who was good at generaling would actually become Caesar next, and wouldn't you know it, he did. And so he then became he became a Roman citizen who was a member of that family, right? He assumed. Yep. In response, Vespasian decided to keep him as a slave and presumably interpreter. After Vespasian became emperor in 69, he granted Josephus his freedom, which time he assumed the emperor's family name of Flavius, and then he defected fully to the Romans. And then we proceeded to see basically all this historical kind of important historical documents that he wrote, which is pretty nice. Okay? So all sorts of stuff going on there. Now, the Josephus problem itself, the way we do it is essentially, it comes from that story of being trapped in the cave. Josephus problem. The idea is basically it's a eeny, meeny, miny, mo, but on a smaller scale. Basically, the idea here is given N soldiers, and you remove every kth soldier from the circle. Okay? So 1, 2, 3. So in this case, K equals 3. N is equal to 41. 1, 2, 3, remove 3. 1, 2, 4, 5, 6, remove soldier 6. 7, 8, 9, you remove soldier 9. You keep, and then when we come back around, after removing 39, 40, 41, now 1 gets removed. 2, 4, 5, because 3 was already removed, right? The question is, given N soldiers, and you're removing every kth person from the circle, where do you want to be standing so that you're the last one standing? Okay? Now, here's the thing. This is a mathematical problem, so it has a mathematical solution, which looks like this thing over here. Given N soldiers and you're removing every kth soldier, there you go. But rather than having you implement this thing, because that's math, and this is not a math class despite our last assignment, we're going to have you simulate this problem, okay? We're going to have you simulate this problem by using a linked list, a circular linked list, and basically going make a linked list of size n and then remove every kth item from it until there's only one item left. And then that will give us the correct answer. Okay? A bit of a morbid problem, sure, but it's got a fun historical historical story. I'll say interesting behind it. And, it's... and again, it's got some very interesting stuff. History is really cool to look at and to see where these things come from. It's a lot, you never know when you might find interesting problems. Or at least problems that maintain your interest, I should say. It's much better than the other problem, than some of the make-work problems I would have. Because this one at least has a story. All right, speaking of stories, the other problem is the solitaire encryption problem, courtesy of this story maker, Neal Stephenson. Okay? Neal Stephenson, he is a pretty influential figure in at least computer science terminology, having coined the term metaverse and other things like that, having the idea of Google Earth before Google Earth was a thing. Like Google Earth was literally looking at at one of his books and going, we should implement that. So the issue with Neal Stephenson, he writes great stories The issue with them is he doesn't know how to stop writing great stories, so I feel like the way his books get published is that his editor sneaks into his house at the dead of night, basically takes whatever's on his computer, chops it off at a reasonable point, and then goes and publishes it. The most, I would say, complete story of his is that you can read start to finish and it feels like a story is Reemdy, which is this. It's a misspelling of readme. Because basically it's a virus file that has a README file that got misspelled on it as Reemdy. So this one's pretty good. It is actually really fun to read. It is a nice techno action thriller. It is, and you learn quite a bit. His other books though are Snow Crash. That's a pretty influential one. And then Cryptonomicon, which is the one for that's our subject for today, which is a book about code breaking in World War II and in the late 90s. Code making and code breaking and kind of that espionage. And you learn quite a bit about it. It's pretty awesome. It was a good read. It is... and as part of it, he reached out to an actual code maker, actual security expert. Okay. Where is that? Yeah. Bruce Schneier, or Schneier? I never know how to pronounce it. I've never asked. And I don't know how to read IPA. So, anyway, he's a security expert. And he basically asked him, "Hey, can you write a code? Can you write a cipher for my book for my characters to use that basically relies off of them using just a deck of playing cards, so they don't need a computer to do stuff?" And yeah, he did. So, and it's not the strongest cipher in the world. Okay, so the difference between a cipher and a code is that a code is spoken in plain English. And basically has a double meaning. Hey, did you deliver the package to Vinny? Yeah, Vinny's gonna get a lesson he's never gonna forget when he opens the package. Right? That's a code. Okay. Whereas a cipher looks basically it searches to basically scramble these things up. Okay. What it looks is to basically take text and then scramble it up so it's unreadable, and then somebody else who knows how to decrypt that cipher can basically take that scrambled up ciphertext and turn it back into plain text, as we call it. The hello world is the hello world version of any kind of encryption is attack at dawn. By the way, so so you'll often see that as our as the basically test message. Now the way this works is using a deck of cards, and if you need a deck of cards to actually, kind of run through this yourself, I've got a bunch of decks of cards in my room. So if you want to just stop by my room afterwards to borrow a deck of cards, I got one of those Costco-sized boxes of decks of cards like a year ago, and I've just been handing them out to students and getting them back as needed. Okay. But what it is that it's basically the idea here is that the way encryption works is that you modulate everything by every single letter by an individual key. Now, the most basic version of this is the Caesar cipher, because Romans, again, Caesar cipher basically modulated every single thing by the same key. Every single letter got the same key, typically 3. And this is basically, here's your ciphertext. Here it is shifted 23, which is, left shift of 3 places. So you basically add 3 or subtract 3 as needed. But you can see basically if you are a literal barbarian, this was a term the Greeks and Romans used, not to refer to non-Roman speakers and non-Greek speakers, because, and I am not making this up, the term barbarian comes from the fact that basically they would go and look, their language, all they say is bar, 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 bar. I am not making this up. It is true. That is where barbarian comes from. So when you're basically, so let's say you are a non-Roman citizen, a person you're fighting against Rome, you intercept this message, and you're barely literate as it is, you maybe learned how to read this, and you get this, you know, that was already a big feat here. Just so, you know, this was perfectly good for them. Eventually, we moved on to doing something manually called the Veneer cipher. This was basically peak World War II, Civil War in World War II. You would use a little locket for this. And basically, the idea is rather than modulating everything by the same key, you should use different values for each key. But using a different value for every single letter chosen at random, called the one-time pad, that involves a lot of security, and that's hard to memorize. So instead, what we're going to do is we are going to use we're going to use a password instead. So let's say attack at dawn, and we use the keyword lemon. So we just repeat lemon, lemon, lemon again and again for the entire length of our password. And so we take the numerical value of each letter, take basically A plus L, use some modular arithmetic to shift it around. Make sense? By the way, I do that modular arithmetic for you in one of the files I gave you for Josephus. So, but basically, A plus L gives you a new letter, which actually turns out to be L because A is 0. T, and so we get this message, and it's quite a bit harder to crack, but not impossible. In fact, in my 8,000 level security class, my grumpy old professor would make us. One of the exam questions was basically decrypting a message using the Veneer cipher by hand, or at least finding out how big the word was, because you can do statistical tests on this. And anyway, so the idea behind this is that between solitaire is rather than using a word, we're going to use the configuration of a deck of cards. We memorize the way a deck of cards is originally configured. The way that, let me go ahead and pull that up now. And I'm sorry I'm taking so long on this, but I figured, I really love these problems. These are really good ones. So here, right, I give you a solitaire, and I do run through all this in this document, right? For simplicity's sake, by the way, we're going to be using only half the deck. So for simplicity's sake, only 26 cards and the 2 jokers. Okay, so you memorize, basically, let's say, where each of these things are. So one of hearts, so ace of hearts is 1, 4 of hearts is 4, 7 of hearts. Then we go up all the way through jack, king, queen, until we get to 14, which is going to be the ace of clubs, right? So you just give each card a numerical value from 1 to 26. And then 27 and 28 are our 2 jokers. Yes, the jokers are different. One is colored and one is black and white in a deck. So you'll have 2 jokers, label 1 joker A and joker B. And you go, and basically you memorize this thing, and you do 5 separate manipulations to figure out what your key is. Then you keep the deck in that new configuration, and do these 5 steps again to generate the next key. So basically you have to do 5 steps to encrypt a letter. And then if you get that message, you do the same thing, but now you're going in reverse to decrypt. Okay? So a video going over this is linked over here, where basically the visual steps of these things are. But again, you'll be using a linked list to basically implement this deck. Now, how do you do this? Programmatically speaking, right? Let me go ahead and see. I think I give you some stuff over here, right? I'm going to go ahead and open up the other file, right? So like I said, it's twice as much work basically because you have a second file. So like I said, I have these 2 functions over here, one for encrypting a letter and decrypting a letter. Notice this, by the way, interesting thing, if you haven't seen this before. Letter, which is a character, minus another character, gives you a value. Remember, all characters, all chars in Java are just integers in disguise. So this subtracts A out of it. In other words, it brings, and A is 97. So it's what we're doing is we're bringing the range of letters from 97 to whatever Z is, to 0 to 25, so that we can actually do math with them. And then I keep it in that range, add the key in, and then I add the A back in to get the resulting letter. Okay. Anyway, so we have these steps here where basically you get the key, which calls all 5 of these steps, and then each of these takes in a deck and modifies the deck. Now, to figure out how to modify the deck, remember, this is simulating an actual handheld process. So here's what I would do. Put the deck on a table, put one hand behind your back, and then proceed to do the steps however you need. If you need to make more space because you're trying to you can't hold on to multiple decks, guess what? You're just going to be splitting and making a new linked list. Okay? In fact, step 3, which is called the triple cut, which involves basically looking for the first joker, looking for the second joker, and then swapping what's above the first joker and what's below the second joker with each other. So kind of imagine like basically a sandwich made of the jokers, and you're just basically swapping the 2 slices of bread, right? That's most easily done by doing very simple while loops with remove methods and adding them to a new deck as you're removing them. Okay, and then adding them back in. Very simple operations because, again, all you can do is just manipulate one card at a time with one hand. So once you kind of get into that mode of thinking, it doesn't become so bad, and it's less error prone. Again, though, in order to do that, you need to have your circular linked list done first. It's a lot of fun, I personally think, it's interesting. Sometimes we get stuff that is off, but what I found. Oh, and by the way, for a test value besides the ones programmed in, if you're using the same initial configuration of 147, etc., that's given in the document, hello, our plain text hello should give snizzy as its as our answer. So, all right. Now, I am of course besides available in class to help you, right? Besides being here, right, and besides during our office hours. First off, did I ever replace my old TA? Yes, I did. Okay. Interesting that somebody reached out to David for help, right? First off, you can reach out to your TA for appointments over Zoom. Also on Discord, David has made it very clear to me that he's more than willing to help with this. If you don't know David, he is the president of TU Dev here, and he's my former TA for this class and for 1051. The only reason he's not TAing this class is because I think it's like his last semester, so he's a bit busy. It just doesn't work schedule-wise. So, but he's more than happy to kind of answer questions and has done so on Discord. He found TAing this class to be a great review for him. And of course, there's me, last but not least, right? Which is, you can come over here and just besides the office hours right after class, you can email me, and I'm more than happy to meet with you. My Wednesday afternoons are now a bit more clear, so that's good. And Wednesday late at night I can probably do. So, but don't feel bad if you need to contact me late. I generally am not hitting, my head isn't hitting my pillow until like midnight anyway. So, I've met students pretty late. There's been semesters where I've taught remotely in Japan. I've not only just gone there, I have taught remotely, and so that necessitates interesting office hours sometimes, and I much prefer to stay up than get up early. So yeah, don't feel bad about reaching out. If I'm available, I will email you back, and if I'm not available, I'll either email you back or ignore you. So, so don't feel bad about it. The only time I'm not really available, guaranteed, is from sundown on Friday to sundown on Saturday. I generally don't answer any kind of student work then. I'm not nearly as religious as that implies, nor my headwear implies. I like to say I'm a practicing Jew because I'm not very good at it. So I need a lot of practice at it. But I do try to take that religious kind of period as kind of an enforced mental health break, and it's done wonders for me. And really, just simply putting limits and boundaries on yourself can be very helpful in general. So I recommend setting up some personal boundaries for yourself, like saying, no, past this time in the evening, I'm not going to do any work because the returns are too diminishing or something like that, because it's important to basically, not torture yourself while you're in school. And last but not least, right, there is free peer tutoring available. So the details are in the syllabus, but it's in the lounge area. I think it's is it 358? It's whatever the lounge is in the back by my office. So, you can always go there for help. And again, reach out on Discord for your fellow students. And again, feel free to work with each other and, help each other on this one. This one is worth it, helping each other.